All right. Hopefully this works this time. Okay. Welcome to class. I am currently at some training right now, but we got to get through the stuff. So how about you do now? I still summarize the goal and stuff. Sweet. Wait, is that the right color? There we go. All right, next. Maybe. Where the heck is my next slide? So 6.6, what are arithmetic and geometric sequences? You already learned about this one. Go ahead and copy all this stuff down. What this basically says is that if it's multiplying or dividing, it's a geometric sequence. That's pretty much it. So I'll give you a second to write it down. Okay, great. Great job. Okay, here are some examples. So you'll have questions like just like this. Decide whether each sequence is arithmetic, geometric, or neither. Explain your reasoning. So I have to tell if it's that, and I have to explain. So it's questions in this one thing. So this one, it looks like I divide by 2 each time to get to the next number. And if I'm not sure, I can just check that in my calculator. And if I get to 60, and 60 divided by 2 gets 30, that means, I don't know, we're all dividing by 2. So since this is dividing by 2, this is a geometric sequence. So that's answer to the first part. Because it's dividing, because it's dividing by 2 each time. If you want to be fancy, you can write common ratio is 1/2, because we're multiplying 1/2 to everything. And that's another way to divide. So this would be my answer. The other question, 2, 6, 11, and 17. It doesn't really look like it's multiplying. This could be a times 3, but then 6 to 11 is a plus 5. That one's a plus 6. So this one is neither. So it looks like plus 4, plus 5, plus 6. This is neither. And explain. So geometric. God. I think I need to get a new stylus or a faster laptop or something. This is freaking slow. Geometric is multiplication or division. And arithmetic adds or subtracts by same number each time. So even though we're adding, it's going up 4, 5, 6. They're not the same. So it's not arithmetic and it's not geometric. So this one is neither. And that's pretty much it. I guess I'll go over an arithmetic sequence real quick. We'll do that over here. Arithmetic is when you add or subtract the same number each time. And that's really it. I think we did that last semester. So arithmetic might be something like -2, 2, 6, 10, 14, because it adds 4 each time. And that would make it arithmetic. So this should be enough to get you through that worksheet, which is due tomorrow. And honestly, this is what's on your test. The next slide, in case you guys, maybe this might come up on the final. I honestly don't know yet. There's a formula to get like the future terms, just like we had one for arithmetic series, there's one for geometry. So your common ratio is the number that's being multiplied by everything, and that's R. R is your common ratio. So if I had like 2, 6, 18, 54, these are all getting multiplied by 3. So my common ratio is 3. And then A1 is what you start with. So that would be 2, because that's where we started. And then N is the number / place you want. So if I wanted the, I don't know, it says nth term. So if I wanted the 13th term, I would have A sub 13, A sub 13 equals, and then A1 is 2. The common ratio was 3, and then N is 13, and then there's the -1. So that matches up with this formula pretty well. And you can see where I filled in the blanks. And then you can work that out in your calculator. And then you get, I honestly don't know. I don't have my graphing calculator on me because I'm at home and mine's at school. Good thing I have that app, that Wabbit Emu thing. It's for Android. Or you guys have your graphing calculators at home. So I'll do this real quick. And so should you. Race me. 2 times 3 raised to the 12. Answer is, what the heck? That is 1,062,888. And that would be the answer. As you can see, they grow pretty quickly, like exponential growth, because it's an exponential function. So that like skyrockets to like 1 million. All right. And then here is another example. Write an equation for the nth term of the geometric sequence 2, 12, 72, and 400. So what I need first is my formula, which is an equals a1 times r to the n minus 1. So I need a1, that's easy, that's the first term, 2. And then r is what I multiply by. So it looks like it's times 6 times 6 times 6. So r equals 6. And then n is, it says find the term. So n equals from over there. So now I just plug all that stuff in. So a10 term is equal to 2 times 6 raised to the, and again we want this term. And then I plug that in my calculator and you get another huge number. And that would be your answer. Questions? Cool. Maybe post it in the Facebook group. Great job. Give yourself a round of applause. Pretty simple lesson. It should be able to get you through everything today while you really miss me. Try not to cry too much because I don't have tissues in class. So that worksheet that our guest teacher has, that's due tomorrow. And if you didn't finish 6.5, maybe because your internet sucks, you didn't understand what to do, take advantage of this time and work with your homies to get this one done to you from yesterday. That's all. Great job. Way to stick through it. I love you all. Here's a smiley face. Oh, here's the cute smiley face. 2 dots and a small U in the middle. Okay. Goodbye. And make sure your calculators are fixed.